So let's. Okay. Okay, it has started. Okay. So first of all, let's see if I can. Okay. Yeah, I can't share my screen to show this etiquette.
Why is that?
I can't share my screen. It says host disabled attendance screen sharing. Because I think it is you who can. Only you who can share now.
If something happened yesterday with Chloe.
Yeah, the same thing. So because she started.
Okay, so I quit. Okay, I come back later. You have to record the whole session. Okay.
Yeah, sure. All right. Okay. So let's see. Uh, can you see my screen now? Can you see the etiquette?
Yes, we can see your screen.
Can you see the etiquette? Online classroom etiquette. Can you see?
No, we can see like a template, templates and Excel one-page calendar.
Okay. Wait a minute. How can I go back? Okay, so let's see if I can go back. I can.
Aki, what happened? Can you share your screen now?
I can't come back to the original Zoom because okay, so how can I
What do you mean you can't?
go back to Zoom? I can't come back.
Are you in the Zoom? You are
Yes,
in the
but how to make it visible for myself, because I can only see.
Sorry, it's along the top. There'll be like a bar along the very, very top. It's only small, if I remember rightly from when I'm at the very top of the screen. It says like sharing options or something like that. It'll be, like I say, at the very top, I think. Sorry, don't know if that helped.
I can't see how I can stop sharing my screen now.
You can't. So what happened yesterday? I remember Chloe told me something similar happened yesterday.
Yeah, because if you come first, you are the host.
Yeah, but I just quit.
Yeah, but now.
Okay, I will join in 5 minutes. Maybe I quit now, and then maybe you can start from on Canvas from Zoom again. Okay.
Okay, I think even me, I need to.
Sorry, guys.
A moment. Okay. Um.
Can.
Okay, so I suppose let's start it. Start it now. I suppose you know the etiquette, so it's not that important to show. Okay, so okay. Why can I see? Okay, now it's better. Okay, now I can see. Okay, so sorry guys, this Zoom is a bit new for me. So I am Agnes Bonivart, and I'm going to hold you the tutorial for Foundation of Data Science this semester. And this is a live session. It is exactly the same as I gave yesterday. And there will be recorded sessions as well. So what we are going to do now, tutorial 1, part 2. Do you have the sheet? Have you found the sheet? It's uploaded on Canvas.
Which
Canvas, right, Canvas.
It's yes, on Canvas. On the tutorial, I mean unit 1. Let's see. On the unit 1.
Yeah, we have.
and unit 1.
Tutorial introduction linear algebra.
Yes, linear algebra, exactly.
Okay, got it.
Sorry, is it linear algebra 1 or linear algebra,
Yeah,
algebra 2?
Part 2.
Part 2. Okay, so that's in unit 2.
Part
Yeah,
2, that means it's in unit 2.
Let's see. It's on the
So what about the part 1?
It's under unit 1, right?
unit 1. It's under unit 1. Unit 1, introduction and linear algebra.
Oh, linear algebra 1.
Yes.
Then. Okay.
Yes, so, yeah, linear algebra 1. And then we have tutorial, introduction and linear algebra 1.
Tutorial and practical. Okay.
Under the lecture introduction, we have tutorial introduction. If you click
Yeah.
on that, we need tutorial part 2. Tutorial part 2, you can see it starts by vectors.
So why not we doing tutorial part 1?
Part 1, part of it will be given online. I mean, not online, recorded.
Part 1 is recorded.
The exercises we don't have time here will be recorded and uploaded.
Okay.
So we are going to do part 2 now.
Tutorial 1, part 2.
Okay.
Part 2 with the vectors. You can see
Yeah.
U and V vectors. So this is every time you can find the tutorial sheet there under the unit so that you can follow it. Or if you want, you can print it in advance if you want, if it's easier for you to follow.
Yeah, of course.
Okay. So okay, so let's start it with the first exercise. Here are given two vectors, u and v. You can see their coordinates. Calculate the following, u plus v. How do we calculate the sum of two vectors? How do we calculate the sum of two vectors?
You
The
will plus
corresponding elements will add
corresponding,
or subtract other elements.
Yes, component-wise, right?
Yes.
So if we have u is 10, 2, minus 6, and we have v minus 3, 0, minus 2, then u plus v is going to be 10
7, 2.
plus
Yeah.
minus 3, yes. Then 2 plus 0, and minus
You-
3.
We can't see your screen, ma'am.
7, 2 minus 8.
I will show you in a moment. So that is 7,
2 minus 8.
2 minus 8.
yes, 7, 2, and minus 8.
Yeah,
Yeah.
right.
Right? So
Yeah.
you add them component-wise, which means that the result is a vector again, vector with components, right?
Yes.
Okay,
Yes.
so the subtraction goes in exactly the same way. So
Yeah.
you can do that. Norm of u,
Norm is the length of the vector, basically.
very good, exactly. Yes, he says it's the length of the vector. It is very good. So how do we calculate that? Norm,
Distance present.
We take under root and plus
Square of the components,
vectors,
sum of
square of
them.
the
yeah,
know,
square of the
you know,
components.
Components. Plus
We have 10 squared plus 2 squared plus minus 6 squared, and the whole thing is under square root, right? So
Yeah.
we have 100 plus
140.
4 plus 36 under square root, so it's square root of 140.
Yes.
Yeah, exactly.
Could you just
Yeah.
hold it?
Yeah.
I can't. If everybody's speaking there.
Okay, so as you can see, the notation for norm is this double dash, double line. So you
Yeah.
into this double dash. This is the notation for norm. As he said very well, that it is the length of the vector. So we square the coordinates, add them, and take the square root. Right?
Yes.
You're right.
The norm of V goes in exactly the same way. So I'm not going to
Root 13.
but yeah, square root of 13. This is the answer. Yeah. You please do it for yourself. The distance 5, exercise 5, the distance between U and V. How do we find the distance?
between
Euclidean distance.
Distance. How do we find the distance of U and V?
subtraction of the square root.
Yes, exactly.
Sum of the squares of the component.
Yes, exactly. Very good. So we subtract the components, the corresponding components. So we have 10 minus 3,
Sub 3.
and then in bracket squared, plus 2 minus 0 in bracket squared, plus minus 6 minus 2 in bracket squared, right? And the whole thing is under square root. So basically, as you can see, it's exactly the same as the former one. That is, we can calculate the norm or the length of the difference vector, right? So we form the difference vector and we find its norm. So we have 13 squared plus 2 squared plus minus 8 squared.
Sorry.
Sorry,
It is minus.
It's
Minus 4 squared.
4. Yeah, thank you. Minus 4 squared. Yeah. So this is going to be. What is the result?
16.
Root 181.
189. Yeah, 189 under square root. 189 under square root. Under square root.
Yes.
Wait. 10 minus 1 is 3, 2 minus 0, minus 6 minus 2.
Right?
Yes.
Yeah, right.
So this is the difference. We form the difference vector, the difference of the two vectors, and then we find the norm of the difference vector. Right?
Yes.
Okay. And then it is the next one is very important, the inner product of U and V. Inner product of U and V. So U times V. What is another name of inner product?
Dot product.
Dot product.
Very good, thank you. Dot product.
Yeah.
And there is a third name of it.
What? The
Orthogonal vectors.
If they are orthogonal, that we have a consequence. But what is the other name of dot product, inner product? And the third name
Scalar
is
product.
Scalar product. Scalar. Yes. Why is it called a scalar product? What is
because it
it?
returns one entity, only one number.
Yeah, because we get only one number.
We get
and
only
which
one
is-
numbers.
which is
No
a scalar
Yes,
vector.
value.
very good. This is it.
No
Because
vector.
the result, okay, what is a scalar? What does scalar mean?
It's the
Scalar
one.
means the single value
Numbers.
or
Single value, single number.
Very good. Exactly. A number. Scalar is a number.
Scalar is a number.
Yes.
yeah.
And the result of the inner product or dot product is a scalar, that is a number. That is why it's
Yeah.
also called a scalar product.
You're
As
right.
opposed to the vector product, because if we form the vector product, then the result is a vector. It's a different thing. But in this case, we have to gain a scalar, a number. I'm saying this because in the exam, many students committed this mistake that instead of a number, their result was a vector, which is not correct, right? That's why I'm emphasizing it. But please don't commit this mistake at the exam, okay? So U times V, how do we form the dot product?
Like we multiply the corresponding
Multiply
elements
the
Very good.
components.
and
Yes,
adding them.
yes,
and
very
adding the
good.
results.
Thank you. We
Yes,
exactly as you say, we multiply the corresponding coordinates. So 10 times minus 3
minus
plus, so we add
0
2 times 0
plus
plus
5
minus 6 times minus 2.
minus 28.
Okay, so we have a plus sign in between instead of a comma.
Yeah.
Okay, which some students did. So we have, it is minus 30 plus
Minus
0
Plus
Minus
0
8.
plus 12 minus 18.
minus 18. Yes, so the
Yeah.
result is minus 18.
Yeah.
So U times V.
Mm.
We don't forget that we have a plus sign between the products, these products, not a comma, right?
Yes.
Okay, because some students put a comma here and here, and they got 3 numbers.
Vector.
It's a vector pole.
It's a vector, but it's not correct.
Yeah.
You have to get a number, okay? And the question is whether these 2 vectors are orthogonal. Are these orthogonal?
No,
No.
because the
No,
angle
since
between them is not equal to 90.
Product is not 0.
Very good.
formula.
Thank you very much. Very, very good. So these 2 vectors are not orthogonal because their inner product or dot product, scalar product is not 0. Okay. So 2 vectors are orthogonal if and only if their inner product is 0. So
Yes.
please definitely expect this exercise at the exam. Definitely. Okay.
Okay.
And when you get this exercise, please write down the conclusion. So after calculating the inner product, please write down this sentence, your conclusion, that yes, these 2 vectors are orthogonal because their inner product is 0. Or no, these 2 vectors are not orthogonal because their inner product is not 0. Okay, please write down to get full marks.
Okay.
Okay.
Sure.
Throughout the tutorials, I will tell you what to focus on and what mistakes not to commit during the exam, right? Based on my experience, what mistakes students committed. Okay. So I suppose this exercise was quite easy for you. Now let's do the next one, the matrices. You probably know that matrices are these tables with numbers. Okay. What is the size of a matrix? What do we call a size? The size of a matrix.
2 cross 2 rows into column.
Yes.
That's
By n.
Yes. So we have a matrix.
Yeah.
We have an m by n matrix. M by n matrix. Then m
Indicates row.
the number of rows, how many rows it has, and n
It indicates
the
number of columns.
N columns.
Okay. What can the rows and columns be considered? They are what, basically? We have
Vectors.
Yes, sir.
Vectors.
that is it. Very good. Exactly. Very well done. Exactly. So the rows are vectors, called row vectors, and the columns are vectors,
as well.
column vectors. So when we do matrix algebra, right, any performance with matrices, what we are doing is we are dealing with vectors, right?
Yes.
Which means we are doing exactly the same things which we have done in the first exercise. Yes. Okay. So first, calculate the following where possible. If not possible, explain why. Very important again. In the exam, if something is not possible, you need to explain why very briefly. You don't need to write so many things. I understand. I will understand your notations. I will understand that you know what it is. Okay. Just shortly, briefly. So we have A plus B. Can we add A plus B?
Yes.
Yes. Yes.
Why can we add them?
Because they have same number of rows and columns.
Yes. So if they are in the same size, then we can add them. How do we add 2 matrices?
The corresponding
Corresponding
Components.
Very good. We add the corresponding entries. So 2 plus 3, 5 plus 6,
5, yeah.
1 plus 2.5.
1 plus 2.5, and 4
4
plus
plus 2.
2. Yeah, so this is 5.
5, 11, 3.5.
11, 3.5, and
6.
6.
Yes. Yeah, right. So this is what we have,
5, 11, 3.56, yeah.
right?
Yes.
We added the entries, the corresponding entries.
Exactly.
Okay. 2a, how do we multiply?
We multiply 2 with
Multiply the
each
scalar 2 with each
Two with
component of
each
matrix
Very
K.
good. Very good. Thank you very much. You multiply all the entries. So 2a is going to be 4,
10,
10,
2, 8.
12,
8.
5, 8.
So for many of you, it might be very well known, but I need to consider those for whom this is the first time when they encounter with matrices. So that's why we need to go through this quickly
Yeah.
to support them as well. Okay. The next ones are straightforward because if you can multiply and add, you can do the other two. So let's do exercise 3. Exercise 3.
3. Diagonal entry.
Yes, find the diagonal and the trace of the following matrix. So we have matrix N, and what is the diagonal? So if the diagonal is asked, what is the answer?
The same number.
2 minus 7, 2.
Yes.
The ones who are coming in the same order.
Very good. So we list the diagonal elements, right? So the diagonal is
2
just
minus 7.
we just
2.
list the diagonal elements. And what is the trace of N?
Length of
Trace is
renal.
sum of
Length
diagonal. Sum of diagonal.
Some.
Yes, we need to
Sum of
add the diagonal elements. So
Yeah.
2 plus minus 7 plus
Minus 3.
2, which is going
Minus
to,
3.
yeah.
2
So we,
plus 2.
So we add the diagonal elements, not only list them when the trace is asked. 2 plus minus 7 plus 2. So again, some students committed these mistakes that they didn't add them, they just listed them. It's not correct if the trace is asked. If the trace is asked, then we have to add the diagonal elements and we get a number, right?
Yeah, right.
Number 4, compute the determinant of each of the following matrices. Okay, so if we have a 2 by 2 matrix, how do we calculate the determinant?
AD minus BC. That's the formula we use for determinant.
Yes. So for a 2 by 2 matrix,
6 minus 5.
it's very easy. So
Yeah, 6
we
minus
have
1.
A, B, C, D. Let's say A is A, B, C, D, then that A is AD minus BC. Right, so this is the general formula, which you have just read, so you know this. Okay, so what is the determinant of A going to be?
6 minus 5,
6
1.
minus 5.
Yes, 3 times 2 minus 5 times 1. Okay, please, in the exam, show me as much calculations as possible, because if you miscalculate something and you just write the wrong number, then there is nothing I can give you mark of. But if I can see you write 3 times 2 minus 5 times 1.
1 times 5.
Miscalculate the last and the number, I can give you marks for this because I can see that you know how to calculate the determinant. It just because of tiredness or whatever, you just miscalculated the end, but I can give you marks. Okay, if you perform how you calculate it. So it's 6 minus 5, right? Which is 1.
Yeah.
Okay, so again, if instead of that A equals 1, because if you miscalculate it and it's wrong, there is no mark I can give you. But if I can see this, I see you know how to calculate it, and maybe I just deduct a half a mark or something, or not, or maybe I don't deduct anything. Okay, but if you give me a wrong answer, there is not. So please give me a chance to give you marks, right?
Okay.
The determinant of B goes similarly, which means
18.
18.
6 plus 12, 18.
18.
That would be 18.
Yes, 18. Very good. 3 times 2 minus 2 times 6.
Yeah.
Okay. Maybe. Oh, okay. I've released the. Okay, we go back. Yeah, I turned 2 pages. Sorry. Anyway, it's okay. We can do this. Doesn't matter. We will go back the formal exercise because I can see we missed something. Anyway, doesn't matter. Let's do C, matrix C, which is a 3 by 3 matrix, right? It's a 3 by 3 matrix. So we have 1, 3, 2, 0, 1, 1, 3, 0, 2. This is our matrix. How do we calculate the determinant of a 3 by 3 matrix?
We ignore the row and column of the selected one and consider the other two ones. Like 1 into
2 minus 1, then 0.
Yeah. And
Okay.
then minus 3.
Then minus
Ignore-
3, then 2 times 0, 3 times 1. Then
Yeah.
plus 2,
Then
0
Before
times
that,
0,
we need
3
to-
times 1.
minus 3 times 1.
Okay. So have you heard of Sarah's rule? What is Sarah's rule? What we do, so I've copied the matrix with this straight line.
1 off.
And
1
what I'm going to do, I
2
copy the
minus
first
1.
2 columns
2. Yeah.
here. Okay, I copy the first 2 columns. So I write down 1, 0, 3, 3, 1, 0. Yes, so all I did, I copied the first 2.
Yeah.
And what we are going to do, we multiply the diagonals. So I form this diagonal, which is 1 times 1 times 2, right? I write down 1 times 1 times 2. 1 times 1 times 2.
Will there be a problem if we do like other way, like
No problem.
not this way?
If you do it in another way, but it is correct, then it's fine. It is fine. Okay? I just have to show you this method.
Yeah.
This is only a method.
The,
When I calculate determinants, I don't do this. I don't need to because I can do it without doing this. But it's an easy method, so we need to provide students with this easy method.
Okay.
So now I have to add the next diagonal 3 times 1 times 3, right? So I do this.
Yeah. 2 times 0 times 0.
So 3 times 1 times 3. Then the next is
2 times 0 times 0.
Exactly this diagonal. 2 times 0 times 0. So plus 2 times 0 times 0. Okay. So these, all of them, we took with a positive sign, plus. Now, with the rest, we take with a negative sign, and we do the other way around. So we go 3 times 1 times 2. Okay, so this, the other diagonal, right?
Yeah.
Other direction. So I get minus 3 times 1 times 2, minus
0 times 1 times 1.
Yes, 0 times 1 times 1. 0
Minus
times 1 times 1,
times
right?
2
The other
times 3.
diagonal. Minus. And the last one is?
3 times 0 times 2.
Yeah, 2 times 0 times 3.
Yeah.
Exactly. So the last one, right?
Yeah.
2 times 0 times 3 equals. So 1 times 1 times 1 is 2 plus 3 times 1 times 3, right? Which is 9 plus 0 minus 3 times 1 times 2 is 6. So minus 6 minus 3 and 0. So what is the final result?
It's 5.
5, yeah.
is it?
Should be
Is 2 plus 9.
so 1 times 1 times 2, 3 times 1 times 3, which is 9, 2 times 0 to 0, which is 0.
16.
Minus 3 times 1 times 2, which is 6, so minus 6, minus
0 plus 0 minus 0, 0. That would be 6.
0 times 0 is 0, And 2 times 0 is 0.
Yeah. So 11 minus 6.
Yeah,
Which is
5.
5.
Yeah, so the result is 5. So 5, right? So do you understand Sarah's rule? Do you understand this Sarah's rule?
Yes, ma'am.
Yes.
All right. Which means we can proceed. So do you want us to do the same with matrix D, or we can proceed? We can go further.
You can proceed.
Sorry?
You can proceed.
We can proceed. Okay.
Yeah.
So please let's jump back to the former exercise where we had these matrices A, B, C, D. So exercise 2. And we calculated the sum of the matrices and we calculated 2A. And let's do the fifth part of it. A times B, exactly, A times B. This is what we are going to calculate now. So we are going to calculate the product of two matrices. That is, in other words, we multiply the two matrices. Okay, can A and B multiplied? Be multiplied?
Yes.
Yeah. Why
Yes.
can why do you
Columns of A must be equal to
Columns
rows
of
B.
A and rows of B are same.
Yes, very good, exactly. So we are able to multiply two matrices if and only if the number of columns of the first matrix equals the number of
rows
rows
of
of the
second.
second matrix. Okay, but this then it follows from this immediately that if we are able to multiply A and B, does it follow that we are able to multiply B and A? So if we swap.
No.
No.
No, again, it should
Not
satisfy the
necessarily. Not
condition.
necessarily.
Exactly. Very good. Exactly. So is it true with matrix multiplication? Is it true that A times B equals B times A? Is it true?
No.
No.
Necessary.
No, because they in the other way. So it's not true. Okay, so I crossed it. It's not true because they might not be multiplicable.
Bro.
Okay. So
The rows and column might
No, online class lo unnam bro.
exactly, they don't want necessarily match.
Edu room lo unna bargain room lo.
Okay, so
Can you please tell which exercise are we talking about?
Payiki vachesa bro. Venki unnadu.
You were on tutorial part 2, and
Is question 2, part 5.
question 2, part 5.
Yes.
So we say that matrix multiplication is not commutative. Not commutative means we can't swap the factors. Okay,
exactly.
A times B is not the same as B times A. Sometimes they happen to coincide. Sometimes they happen. But in general, we can't swap the factors. So in general, A times B is not the same as B times A. Okay, so you need to be careful of the order of the matrices. Please, would you mute your microphone? Okay, so let's calculate A times B. So what I do, I write down A, 2, 5, 1, 4, 3, 6, 2.5, and 2. Okay, so what I did is only just copied them next to each other. Okay, what we are going to do, we are going to have a matrix as a result. A matrix as a result. What we are going to have here, that is the first row, first column element of the product matrix is going to be what? So again, the first row, first column entry is going to be what? What do we need to do? We need to take
2 into
the first
3
row,
plus
first row
5
of
into
the first
2.5.
matrix and the first column of the second matrix. And to do what?
Yeah.
What are we
So-
doing?
Add them. Add them.
First column of the
Inner
result
product,
matrix.
dot product.
Thank you very much. That
Dot
is it.
product.
That is it. We are going to calculate the dot
Dot
product
product, yes.
or inner
Yeah.
product of the first row vector of the
Yeah,
first
yes.
matrix and the first column vector of the second matrix. That is, we need
A dot
Three
2
product.
times
2
3
times 3
That is 3.
plus 5 times
Plus
2.5.
5
5
times
5.
2.5.
2.5. Yes, so 2 times 3 plus 5
6.
times. Okay, so the
2.5.
dot product of these two vectors. Okay.
Yeah.
Then which follows, if they happen to be orthogonal, then what would be the result?
0.
0.
Yes. So if the two vectors happen to be orthogonal, then their
Then
dot
dot
product
product is 0.
is
Will
0.
be 0.
Yes. But in this case, it's not 0. But let's see what is it. So we have 2 times 3 plus 5 times
2.5.
2.5. Okay.
That is first.
Now we are going to calculate the first row, second column element, first row, second column. That is the dot product of the first row of the first
2
matrix.
times 6.
Second column.
Yes, with
2
the
times-
second.
2 into 6 plus 4 into 2.
2 times
So
6
we have
plus 5 times
yes,
2.
2 times 6 plus 5 times 2.
5 into 2.
2 times 6 plus 5 times 2. Yes.
Same goes
Now-
for the third column.
Now we are going to calculate the second row, first column element of the product matrix. That is the dot product of the second row of the first matrix, right? With the first column of the second matrix. That is 1 times 3 plus 4 times 2.5, right? And finally, the second row, second column element of the product matrix is the dot product of the second row vector and the second column vector.
Second column of second vector. Yeah.
That is 1 times 6 plus 4 times 2, right? So what is the result?
18.5, 22, 13, 14.
18.5, yeah. 22, right?
13, 14.
Yeah. 14, yes. And 13, 14, right?
Yes.
Is it what you got?
Show it on the camera, please. Yeah. 8.5, 22, 30.
Okay.
Yeah.
Are you fine with this?
Yep.
Okay. So let's see the next one, A times C. A times C. Are we able to multiply A and C?
No.
A and C.
No.
Are we able to multiply?
No.
No.
Mm-hmm.
No.
No, you can't. Why?
Because the
Because
columns and rows
Because the columns and rows of A and C are not equal.
Exactly. So if I wanted to try to multiply them, right? I would take the first row vector of matrix A and the first column vector of matrix C, and I would start calculating their dot product. I would do 2 times 2 plus 5 times 2, and then there is no more entry in matrix A by which I could multiply the next entry in C, which is a 0. So there is I got stuck. I get stuck, right? So it turns out that it's not possible. So again, please expect this exercise in the exam. And if the two matrices can't be multiplied, then please conclude that the two matrices can't be multiplied because the number of columns columns, not rows, number of columns of the first matrix doesn't match or doesn't equal with the number of rows of the second matrix. Okay, so please write down this explanation, this sentence. It's enough.
Can you please repeat again?
So if you find that the two matrices can't be multiplied, then at the exam, please write down that these two matrices can't be multiplied because the number of columns of the first matrix doesn't number of columns of the first matrix doesn't equal the number of rows of the second matrix.
Yes.
Okay, so this one sentence, we don't need more. From this, we know that you know. Okay, but you need to write down. So just only writing that they can't be multiplied, you won't get the full mark unless you explain why. Okay, so just this one sentence, only this sentence. Okay, as an explanation.
Sure.
Now, let's do the inverse. Inverse, that is 9. So in exercise 2, part 9, we have this a raised to the power of -1. A raised to the power of -1, what does it mean? Well, how can we raise a to the -1? What does it mean?
It 1 by a, according to the mathematical.
It's a notation. It's a notation. Yeah, it's a
Inverse of
notation.
matrix.
Very
1
good.
by delta into.
It means the inverse. Take the inverse.
Yeah.
Okay,
Yes,
so this -1 in the exponent is a notation, meaning find the inverse.
Yes.
Find the inverse. Okay, how do we find the inverse of a 2 by 2 matrix? How do we
1 by
find
inverse of A, determinant of A.
Yeah.
Adjacent of a multiplied by.
Swap the
multiplied
places of
to
first element and last element, and then
second element and third element.
Yes, so if we have a matrix A, B, C, D, then the inverse is going to be 1 over the determinant, and then we need to swap the main diagonal element, and the other two are going to be multiplied by
Change
9.
the sign.
Yes.
So this is the general formula. Okay, then it follows right away. See, 1 over determinant. So we need to multiply by the reciprocal of the determinant, or in other words, we need to divide by the determinant.
yes.
So what follows from this? That we need to divide by the determinant.
Sorry, what?
You mean determinant of A?
Sorry?
Could you repeat the question?
So we have that we need to divide by the determinant, right?
Yeah.
Because division or multiplying by its reciprocal is the same thing.
Yeah.
So what does it tell us that we need to divide by the determinant?
AD minus BC.
What do we know about the determinant then? What does the determinant has to fulfill?
It should not be 0.
Thank you very much. Exactly. The determinant can't be 0.
Yes. The inverse is not possible.
Exactly. Very good. So since we need to divide by the determinant,
yes,
we are able to calculate the inverse of a matrix if and only if the determinant is not 0. Is not 0, because what if it's 0?
It's undefined.
Then it would become undefined. Yeah.
It's not defined. So 1 over 0, please note, it doesn't equal 0. It doesn't equal infinity. Okay? Yes. 1 over 0 is not 0. It's not infinity. But it's not defined. It's not defined. Not defined.
Not defined.
Dividing by 0 is not defined. Okay? So, if in the exam you are given a matrix you need to calculate the inverse, and you find that the determinant is 0, please don't write 1 over 0. Don't write something like this. After calculating the determinant and you find it is 0, then please just write down that this matrix doesn't have an inverse because the determinant is 0 and there is no further calculations. There is no need. You can't calculate anything further, okay, because you can't divide by 0. So don't write 1 over 0 times the matrix. It doesn't exist. It's nonsense, right? Okay, again,
Yes.
in the exam, if you need to find an inverse of a matrix, first step, you have to calculate the determinant. And if you find that the determinant is 0, then there is nothing to calculate any further. There is nothing to calculate any further. You just write down the sentence that this matrix doesn't have an inverse because the determinant is 0. Full stop. Okay? And you get the full mark if you write this sentence down. Okay? Please don't write such thing that 1 over 0. Okay? It doesn't exist.
Okay, ma'am.
Okay, ma'am.
Okay, in our case, what is our matrix? We have matrix A that is 2, 5, 1, 4. Okay.
8 minus 5, 3.
Which means we need to calculate the determinant is 2 times 4 minus 1 times 5, which is 8 minus 5, which is 3. Okay.
3.
We found that determinant of matrix A is 3. That is not 0.
Inverse
means inverse exists. Now we can go further. Now we can go further. Okay.
Yes.
If it was 0, we would stop here. Okay.
Yeah.
Now, what we need to do? The inverse equals, we just write 1 over 3 times, we take the matrix, we swap the main diagonal, so we have
4 minus 5 minus 1, 2.
Yes, and we multiply by minus 1.
Yeah.
2 by 3 and 2 by 4 by
1
3.
over 3. Okay, so because dividing by 3 is the same as multiplying by its reciprocal. So 1 over 3 times, and we swapped the main diagonal elements and multiplied by minus 1. The other.
Yes.
Professor, can we use calculator in exam?
You can't. He won't let you. Won't allow you to use calculator. But these are very easy numbers, right?
Sorry.
Sure.
Sorry, Agi. I'm chopping here. Okay. For this year, it's very unusual. So the final online test should be something like an open book test. So you can use a calculator this year. However, I mentioned in one of my videos, I said, okay, you want to be a good data scientist. Okay, data scientists won't be afraid of numbers. So it's better if you, during the whole module, practice calculation on your own without rely on calculator very much. I think that will be good. Sorry, Agi, back to you.
No problem, no problem.
Thank you, Professor.
Thank you, Professor.
Okay, so this is the inverse of A. Okay, so what? Okay, what inverse of B? What is inverse of B going to be?
Inverse of B.
Inverse of B. Now let's calculate inverse of B. The matrix B. So
6 minus 0.5.
Okay, so B, matrix B equals 3, 6,
2.52.
and 2. Okay, the determinant of B is 3 times
6
2 minus 6 times 2.5, which is 6 minus
12.5.
6 minus what?
6 minus
15, isn't it?
15. Yeah.
So the final result is minus 9, right? Am I right? It should be minus
Yeah,
9.
it's -9.
That's
Yeah.
right.
-9.
The
6, 9. Yes,
determinant.
-9.
Okay, so we've calculated the determinant. It came out not 0. So now we can proceed. Okay, again,
Yes.
if it was 0, we would stop here and just write the
Yes.
sentence that the matrix doesn't have an inverse. Now it has, so the inverse equals 1 over -9 or minus 1 over 9. It's the same thing. And then we swap the main diagonal and multiply by -1 the rest. Okay, then in the next exercise, the question is B inverse times B. B inverse times B. What do we expect this to be? The result should be.
Identity matrix.
Very good. Exactly. Thank you very much. Okay. Because what is the inverse? How is inverse defined? Not only in
One
this
by
case,
B.
but
Yeah, like
in any time. Also, if we consider numbers.
inverse the reverse of original numbers. You can say.
Or the inverse of a matrix is a matrix by which, if we multiply the original matrix, we get the identity matrix. Okay.
Yes.
So if we calculated the inverse correctly, then the product has to be 0. The identity matrix. What is the identity matrix?
Ones are
Diagonal. Ones are in
Yeah,
diagonal.
one on the diagonal.
Yes,
Diagonal.
ones are in the diagonal and 0 everywhere else.
Yes.
Yeah, is the diagonal. Okay, so in case of an inverse, if you multiply B by B inverse, or the other way around, B inverse by B, both the results have to be the identity matrix. Okay, so in this case, the order doesn't matter whether it's B times B inverse or B inverse times B. Both have to give us the identity matrix. Okay, but in general, we can't swap the order of the factors when multiplying matrices because they can give us different results, and as we discussed, they might not even be multiplicable in the other way around, right? Because the columns and rows, number of columns and rows might not match in the other way around. Okay.
Yeah, it does not follow commutative property.
Yeah. Okay. Now, 13th, E transpose. So we have the 13th exercise, the transpose of E. We can see E. This is matrix E is a 3 by 3 matrix, and we need its transpose. What is the transpose of a matrix?
Rows into column. The
Column
column becomes rows.
Very good. So what we do is we reflect on the main diagonal. Okay, so the main diagonal elements remain the same, they are fixed. And as a mirror, we reflect the rest, but it is the easiest to perform in the way you are saying, that rows will become columns and columns will become rows. So the transpose of E, the first row was 1, 3, 2. Now this will be the first column. So I write it as column 1, 3, 2.
1, 3, 2,
the second
0, 1, 1.
row was 0, 1, 1. Now I write it as a column 0, 1, 1. The third row was 3, 0, 2. Now I write it as a
column 3, 0, 2.
Yes. Right? So this is the transpose. We swap the rows and columns. This is the transpose.
Yeah.
E transpose. E transpose. Okay. And now let's go to exercise 5. Exercise 5.
Yes.
We have a matrix L filled with these square roots and this 1 over square roots. E likes these square roots and 1 over square root of 3, whatever. So please be familiar with calculations multiplying these square root things because E likes giving these things. So if you happen to have these in the exam, please be confident how to multiply these square roots with each other. Okay. So what we have here, the question is whether L is an orthogonal matrix. Whether L is an orthogonal matrix. This is the question. Okay, when is a matrix orthogonal?
And all columns are
When
orthogonal.
transpose of L into L equals to identity matrix.
Yeah, so that its rows are orthogonal
Yeah.
to their columns, right? Their
You
rows
have
are
to check
orthogonal.
every column, like A into B first, then A to C, then
Okay.
B.
Or
If L into L transpose is 1.
yes, so the columns are rows are orthogonal to the columns. That is, how can we check such thing that whether they are orthogonal? Because we have row vectors and we have column vectors. We have to check whether they are orthogonal. How can we check? What is the method? How can we figure out whether two vectors are orthogonal? How can we find it out?
Dot
Its
product.
transpose is equal to its inverse.
Yeah, someone said, the boy
Yeah.
said, what did you say?
Dot product.
Yes.
Dot product, inner product, maybe if it's 0,
Exactly.
then it
Very
is.
good. So if two vectors are orthogonal to each other, then their dot product is 0. Okay.
Yeah.
So
Yes.
if we want to check whether the rows and columns are orthogonal of a matrix, we need to form their dot product. Okay. And those ones, so if they are orthogonal, of course,
Yes.
0. And what happens when we form the inner product, a vector with itself, right? Because if we form the dot product of each vector with each vector, then we need to calculate the dot product of a vector with itself. Can a vector be orthogonal to itself? A vector, can it be orthogonal to itself?
No, I don't think
No,
so.
it can't.
No,
It's
orthogonal
parallel.
means a 90-degree, and if
Yes.
so it's not
So-
possible, I guess.
Yes, exactly. It's not possible. Okay, which means when we multiply, we multiply the vector with itself, then we need to get 1. So how do we do this? What should we do? What
Like
is
each columns, first A, B, A, C, then B, C, I guess.
Why did we deal with the transpose in the former exercise? Why did we deal with the transpose? What does the transpose do?
Exchange the rows and columns.
Yes,
like rows
exactly. So the easiest way to find out whether a matrix is orthogonal,
Yes.
to multiply the matrix with its transpose.
Transpose, and it should be identity matrix.
Very good. And if the matrix is orthogonal, then the result matrix, the product matrix, will be the identity matrix.
Identity, yeah.
So again, what we do?
Repeat, please.
So again, the question is whether L is an orthogonal matrix. This is the question.
Yes.
Okay. As we said, that a matrix is orthogonal if their rows and columns are orthogonal to each other. And this is the case if when the matrix multiplied by its transpose gives the identity matrix. Okay? Because in this case, what we do, right? In this case, what we do, because what is matrix multiplication? As you said very well at the beginning, it's forming the dot product of the row vectors of the first matrix with the column vectors of the second matrix, right? So we multiply the dot product of the row vectors and the column vectors, right? This is what we are doing. The easiest way is to multiply the matrix by its transpose. Okay? And if the different columns and rows and columns are orthogonal to each other, then we have to get a 0. Okay? And in the case where we multiplied a vector with itself, We can't get a 0 because no vector can be orthogonal or perpendicular on itself, right? They are parallel because it's the same thing. We have to get a 1. So please, in the exam, if this is the question, write down the definition that if L times L transpose equals the identity matrix, or L transpose times L, it doesn't, in this case, the order doesn't matter. L times L transpose or L transpose times L, same thing, equals the identity, then it follows that L is orthogonal. So this is the definition. So please write down this at the exam. Okay.
Don't we need to calculate the whole matrix to prove that?
Sorry,
For
say
this
that again.
question. Yeah, the question says if L is an orthogonal matrix, don't we need to calculate the whole matrix, like to mathematically show the transpose of L into L equals to 1?
Yeah. We need, yes, yeah. This is the next second step. So this is the first step to write down what we need to check. Okay. So this is kind of definition. You write down. Next step, we perform the calculation. Okay. So write down matrix L. This is 1 over square root of 3. Again, 1 over square root of 3. 1 over square root of 3. Yeah, 0, 1 over square root of 2, 2 over square root of 6, minus 1 over square root of 6, minus 1 over square root of 6. Right? This is the matrix times, and now I make the transpose. That is, I swap rows and columns. So I will have 1 over square root of 3. Right? 0, 1 over square root of 2. And 2 over square root of 6 minus 1 over square root of 6 minus 1 over square root of 6. Okay? So L transpose, and we need to multiply them. Original L transpose. And we need to multiply, that is, form the dot product of the first row vector with the first column vector. See what we get. Okay? Then first row vector with the second column vector, and so on and so on. Okay? So please do it. So if we get, if the result is the identity matrix, then
L is orthogonal.
Yes, and please, in the exam, write it down, write down your conclusion that since the product of L and L transpose is the identity matrix, L is an orthogonal matrix. L is an orthogonal matrix. If you get the identity matrix. If you don't get the identity matrix, then please write down that since the product of L and L transpose is not the identity matrix, that's why L is not an orthogonal matrix. Okay, so please write down this explanation or conclusion to get the full marks.
Sure, ma'am.
Right. So again, in this question, in the exam, please write down this and the definition. So when do we call matrix orthogonal? When its product with its transpose equals the identity matrix. Then L is orthogonal. You write down this. Then you perform the calculation, the multiplication. You get a result matrix. And if you get the identity matrix, you conclude that since the product of L and L transpose is the identity matrix, L is orthogonal. Or if you get something different, not the identity matrix, then
it is not orthogonal.
Not orthogonal, exactly.
Yeah, this is not orthogonal.
In that case, yes. Okay, just one more thing with this. So we have that if a matrix is orthogonal, then multiplying it by its transpose, it gives the identity matrix, right?
Yes.
What does it follow? What does A transpose have to be? What is A transpose have to be? So that if we multiplying it by the original matrix, we get the identity. What does it have? Thank you very much. Thank you very much. Exactly.
L transpose.
Inverse, okay? Because by definition, if a matrix is multiplied by its inverse, then we have to get the identity matrix.
Yes.
In case of orthogonal matrices, the inverse of the matrix equals the transpose, which means it's very easy to calculate the inverse matrix, right?
Yes.
It's very easy. Sixth part of first question. Okay, someone is asking me to explain the sixth part of the first question. The first question. Okay, so the sixth part of the first question was the inner product of the two vectors, u and v. Inner product, with other words, dot product or scalar product, same thing. Okay. How do we calculate the dot product or inner product? We multiply the corresponding entries of the vectors. So first component with first component, second component with second component, third component with third component, and we add them. So in this case, we had 10 times minus 3 plus 2 times 0 plus minus 6 times minus 2. And we get a number. So the inner product of two vectors is a number, a scalar, okay? In this case, we got, it was minus 18. And we need to conclude that since the inner product or dot product, scalar product of these two vectors are not zero, is not zero, that's why these two vectors are not orthogonal. If we find it's zero, okay, if it was zero, then we would conclude that they are orthogonal. Right?
Yes. Yes.
So someone asked me. Okay, so I will record a tutorial with the exercises we didn't have time today on this sheet and on the homework, and it will be uploaded. And next week, we'll continue next week. And again, you will find the sheet, the exercise sheet, under the unit, I suppose, right? Yi, are you here?
Yes, I'm here. I think actually what you try to say is that for those questions you haven't covered, you will give live session to explain them tomorrow at 2 to 3, right?
Oh yeah, okay, 2 to 3. Yeah, so 2 to 3, I will give a live lesson tomorrow to cover whichever questions we didn't have time for today.
So where can we find that link? That link would be uploaded as well?
Yes.
You will be taking session from the tutorial you just read today.
So kind of, it will be a tutorial with the questions we didn't have time today from this sheet.
So you're discussing the tutorial that discussed today, right?
Yeah, this is, but we didn't do all the exercises. We needed to swap some. For example, we need this multiplication and whatever. So I will give that tutorial tomorrow. And we will send the link.
But it will be recorded. If you cannot attend, you can watch video later.
Okay.
Okay, ma'am. Thank you very much.
This session is being also recorded, right?
Yes, it is recorded.
Aki, you recorded, right?
Yes.
Yeah, it says
How
here.
about yesterday's session? Like we didn't know that we had this session's tutorial because we didn't find it under unit 2. And then suddenly we came to know that, yeah, yesterday's session, tutorial session, is that recorded and uploaded in the module?
Considering the content, okay, teaching content, yesterday's session is identical to today's, this one.
Yes, yesterday's session is identical to this, exactly that. I've given exactly this, so it's enough to attend only one of the two.
Oh.
So this one was for those who were not able to attend yesterday because of any other things to do or something, some other lecture or.
Where can we find the link of this recording? I mean, if I have to see later.
Yes, I think the video will be available in about 24 hours.
Link will be available after 24 hours. Okay.
Yeah. Okay.
Okay.
So I think, Aki, you can end the meeting. Thank you very much for everyone coming, and thank you, Aki. And you can end the recording now.
Yes, and tomorrow, if you attend if you have any questions, please let me know tomorrow, right? Ask me the questions.
Ma'am, last question, please.
So again, if tomorrow I will give a tutorial on the questions we didn't cover today. But if you have any questions, please let me know. If you are struggling with anything.
Ma'am, one last question, please.
Yeah, it's 2 to right, 2 to 3. 2 to 3.
Okay, I think someone just asked about what happened on Thursday's practical session. Please be patient. I'm also waiting for instruction from university. As long as I hear anything from our university, I will, put instruction online.
Yeah, because I can see that we have this practical session on campus.
Yes, yes, we know. But like I said, we need further instruction from university at university level. Okay, I will update as long as I got information.
Okay, thanks, Professor.
Do you have any reference book to